Okay, our next section of notes is on medians, altitudes, and bisectors. So a median is a segment whose endpoints are a vertex and the midpoint of the opposite side. So if I'm going to draw a median on this first triangle from angle A, I will make my point at angle A. That's the endpoint at the vertex, and it's going to be going to the midpoint of the opposite side. So I've got to cut this side exactly in half, so I have two congruent segments. This is my median of this first triangle. In the middle triangle, I'm going to start at a vertex and I'm going to cut it equally in half the other side. This is my median for this triangle. And in my last example, from vertex A, cutting CB in half, here's my median. All right, so now an altitude is the perpendicular segment from a vertex to the line containing the opposite side. Sometimes altitudes are outside the triangle. If I'm coming from vertex A and I want to be perpendicular, I need to be at a right angle to this opposite side. And so this side right here is the altitude for this triangle. It is outside the triangle. In the next example, from vertex A, if I want to be perpendicular, if I want to be the altitude, I need to draw it straight down. And on the last example, from vertex A, sometimes your altitude can be a side of the triangle. So we can say on the side of the triangle, or on one side of the triangle. Now, a perpendicular bisector is going to be perpendicular and at a midpoint. So it is a 90-degree angle at its midpoint. All right, so let's draw from vertex B. If I'm going to be a perpendicular bisector, I've got to cut AC exactly in half, and I've got to be perpendicular. From vertex A on the second triangle, I'm going to bisect that side and be a right angle. And on this last, I'm going to be perpendicular and bisect. So you don't always have to go from a vertex. This is a perpendicular bisector of this triangle. What you need to notice are that I've got the congruency marks, meaning I've bisected a side, and I've got the right angle, meaning I've got the 90-degree. Okay, an angle bisector, this is a ray that divides an angle into two equal parts. All right, so if I want to be an angle bisector from angle A, I'm going to start at the vertex A and just go to the opposite side. I'm going to show my congruent angle marks just like this. In the second triangle, if I'm going to be an angle bisector, I can draw it like this. And in the last triangle, if I'm going to bisect angle A, I've got to have two congruent angles right here. And make sure you're showing they're congruent by putting those two little marks. All right, just a couple more examples and then you'll have time to practice. So on this triangle here, let's name an altitude. Remember, an altitude is going to be a perpendicular segment from a vertex. And so if I'm looking at this triangle here, I can see this is an altitude because it is from a vertex and it is perpendicular on the other side. So that'll be BF. A median. Now, a median It says a segment whose endpoints are a vertex and the midpoint of the opposite side. So I need to be, a median is going to be a segment whose endpoints are a vertex and the midpoint of the opposite side. So how about CD? If I'm going to be at the midpoint, I've got to show congruencies. So I'm at the vertex and the midpoint of this opposite side, so that's going to be CD. And the last one is an angle bisector. An angle bisector is a ray that divides the angle into two equal parts. And so if I look at this angle A, see how we have two congruent little parts? This will be my angle bisector. And so that's AE. All right, let's take a look at one more example, this guy right here. See if you can name an altitude, a medium, and a perpendicular bisector. All right, so an altitude is perpendicular from a vertex. I can see perpendicular from a vertex. It doesn't have to bisect, so it doesn't have to be over here. It can be outside the triangle. And so in this case, RQ is an altitude. A median, that is going to be a segment with an endpoint at a vertex and the midpoint of the opposite side. So SV can be a median. It starts at this vertex and it is cutting this side into two congruent parts. And so this would be SV. And an angle, oh, I'm sorry, the last one's a perpendicular bisector. That means I need to be perpendicular and, let me go back. I don't need to be perpendicular on the median. So I can actually call this guy, I have to be perpendicular on the bisector, but not necessarily the median. So let's go ahead and change our work. Let's go ahead and make RU the median, and then the perpendicular bisector SV. Sometimes you got to take a second look. All right, time to practice.